Swayam Prabha. Digital India. Educated India.
Good morning everybody and welcome again to our course on Introduction to Mechanical Micro Machining. So, till now what we have seen that we are using a big machine and we are doing some type of micro milling operation. That means the size of the machine is not small scale and the size is almost same as the conventional CNC machine or the conventional machine which we are using routinely in our workshop and some production unit. So, now objective of this today's class is that what happens if we reduce the machine size itself, because we know that we want to fabricate a small component and in terms of few millimeter or few microns only, then why we need a big size of machine, because there are lot of problems related to the cost as well as space also if you use a big machine. So, here our objective is to find out that what are the reasons that we can select a smaller machine and we can further improve the space availability as well cost issues. So, let us continue our topic on micro machines. So, what we are doing? So, this is also one of the micro machines which is available with us, and now if you see the size is almost height is at 2.76 meter and the width and the length is around 1.5 meter in both the size. So, size is very high, and if you see this particular spindle part, so this is the spindle and this is the workpiece location where you can do some type of micro machining operation, and this is the one of the components which is being machined in the same machine, and the size of that component is around 25 millimeter or something. Now, you can understand that when you want to do machining at this such a scale, when you are looking at a tens of millimeter only, then actually you are using a very large amount of space for doing same thing. So, what to do in this case? So, what is the problem with this particular system is that machining of micro features or micro components using a big size machine, right. So, this is what is problem, because you are cutting a small geometry, but you are using actually very large amount of space in the workshop or whatever production space you have. So, now what is the objective of this today's lecture is that what happens that if we reduce the size of the machine itself. Now, here you can see that this is a micro factory, consists of many different machines. It is a micro milling is available, micro punching is there, then robotic arm is there which moves the component from one location to another location, and this is you consider this is a lathe, and consider micro lathe. So, it can do machining turning at a micro scale, and you can see the size of this lathe also, it is almost a palm top size. So, here we will see that what are the different problems associated with this, and what are the advantages of going with this type of micro machine components or the micro machine itself, right. So, what is the today's situation, that majority of the micro machine tools are based on the conventional ultra precision machines. So, they have size almost same as the conventional CNC machine or the machine which we are using in our day to day life. So, now there is a strong interest to build a small scale machine tools to fabricate micro components, right. So, now because we know that we have to get small components only. So, let us try and see that whether it is feasible to reduce the size of the machine also along with the size of the component. So, what was the machine the motivation of doing this thing, that it minimizes the cost and size while increasing the flexibility. So, we will see all the advantages also and some disadvantages also when we go with micro machines. But there are problems also associated with this, that because accuracy of the micro machine tool is not yet on a par with the conventional ultra precision machine tools due to their lack of rigidity and the base vibration. Because we know that size of the machine itself is very small. So, even a small amount of vibration is enough to disturb the whole situation of the machine tool, micro machine tools, and rigidity is also very less here because we are going in a small scale of the machine itself. We will see these things in more detail in the next few slides. Right. So, why we need this particular micro factories or the micro machines? Because the major importance is saving the energy in the manufacturing, because we know that if you reduce the size of the component, you can save many things. So, let us see this thing. The first is the physical plant and its running cost, right. So, here advantage is here that if you reduce the size of the machine, then what you can, it will it can be accommodated in a small space of the physical plant. So, that is the advantage of that. You can mount more than one machine with a space which is already sometimes consumed by the bigger size machine. So, physical plant and running cost is also low in this case. Cost to the environment is because now if the size is very small, then you can use a small amount of coolant and some type of temperature related things also. So, environmental point of view also cost is very less here. And difficulty in harmonizing machines and people. So, that is the things which is related to the bigger size machine, because if the size of the machine is very big, then what happens that you have to actually move around the work machine and then you have to find out the what things are there, and sometimes it is difficult to operate also when the size of the machine is very big. So, at that time it is difficult to actually harmonize the machines and people. But if the size of the machine is small, then what happens that you can actually get more closer look to the machine by operator and some other person also. Right. So, when the part to be assembled and the processes are small, excessive space will be inefficiently utilized and lead to the higher cost. Now, we know that our components are very small, and if it is a single component it is going to use for the later application, then we are just working with a single component. But if there are many components which will be assembled at the later stage, then what happens that then you have to prepare a assembly session also there. But if you do all these things with a bigger size of machine, what is going to happen that actually you are not utilizing the space and the other things very efficiently. So, by using micro factory, what we are doing, we are actually efficiently utilizing the space, and then it leads to the lower cost of the space and some other things also. So, good idea is to use small machinery for production of small parts to better meet the current industrial demand, because now you can see that cost of the land is also very high, and if you can install only 2 or 3 machine, then the total output will be the efficiency of that machine only. But if you mount 100 machine like that in a small machine and those machine can do the same work of the 3 machine, then obviously your output will be very high, and you can actually increase the total profit out of it. So, let us see what are the advantages of expected from the micro factories, because if you see that there are not so many machines available in this particular size of the machine tool, but still people are trying very hard to get these things matching with the conventional machines which are very bigger in size. First thing, let us see about the economical aspect, that how it is better in terms of economics. First thing is the reduced need for capital investment in the machinery itself and the facility, something like this. So, land, space, building, power, source, environmental condition, these things are also very important. Now, if you see this first thing, that machinery itself, now why it is that? Because now if you see that your machine is, consider it is in 30 centimeter by 30 centimeter by 30 centimeter. Right. So, it is a 1 foot by 1 foot by 1 foot. Now, consider that you want to make something out of it, then obviously our material requirement is low. Material requirement is low. First thing is that. Now, second thing is that when you are, because ultimately this is also machine. So, you will find all the components which are available in the bigger size machine, but then that means you have to machine this component, then you have to assemble. So, second is the processing sequence will be very less, because now you want to do machining of a very small component. So, component of the machine are small in size. So, what is the advantage? Then you can actually quickly, easy, not easy, but you can actually write the quick, because still we are working with the micro domain only. Quickly fabricated compared to bigger size component, correct. So, these are the advantages going with this thing. Then related to facility, because now you have to spend less money in the land, because with a small land itself you can start operating this machine. Land is obviously, the space is obviously related to that thing. Then space in the building, because now it is not that you can directly operate this machine in an open environment. So, you have to actually create one type of envelope, and that envelope will be very small. Power sources are less, because now all the motors or whatever rotating elements are available in this case, that will require very less amount of power, because the power requirement is very less. So, you can actually save the energy, saving energy. And the environmental conditioning, that is related to the how you are actually making the space for this particular machines. Machine can be constructed with the more expensive material that exhibits better engineering property. Now, till now what we were doing, now suppose we take the example of some type of surface now which are in the relative contact. Now, you can see that this is one surface and there is one surface on the top of that. So, this is the another surface. Now, what happens that this both surfaces are in relative contact. Now, this is in moving in this direction, both directions. So, there is a very large amount of contact here. Our objective is to reduce the wear and friction. So, now there this material size you consider, this size is very big. Now, you consider this size is 5 meter and this size is 10 meter. Now, because of this size, what happens that you cannot actually make this particular component with a very costly material, because now what happens that you will end up with the amount of energy or amount of material which you are putting here, it is very large, because what happens here that the contact is on this top surface only, rest of the material does not play any important role in the particular process. So, now here what we have to do that, mostly we do that we provide some type of coating on the top surface. So, to avoid wear, a hard coating is provided on the top of the surface, right. So, we provide some type of coating here. So, that coating is there on the top surface with a few micron thickness, and then you can actually reduce the friction and the wear between the two surfaces. Now, here what is the objective of this example? Now, you can see that your objective is to get this wear, friction and wear very less, but we are using a base material with some type of cheap material. So, base material is cheap and coating material is costly, right. So, we are using a very thin layer of the coating which is costly, and that is what is required to reduce the friction and wear. But now, if you see that if you whatever material you are using for coating, if you use the same material for fabrication of this 5 meter by the 10 meter part, then the cost is very high. But to avoid that cost, what we are doing that base material is different, which is very cheap, but you are using some costly material here on the top of it, that is to save the material. But by saving this material, what we are doing, we are actually increasing the number of steps required for fabrication of this surface. So, that is the problem with a bigger scale. But now, if you say that you know that your material requirement is very less here. So, now this thing that we are actually using a very small component, right. So, component requirement is, suppose it is, this is the component, and now you see that this component is again the same thing where whatever we are discussing, let us consider 1 foot by 1 foot by 1 foot in all the cases. So, now the size is very small. So, you can go with the expensive material. Why expensive? In the sense that which can fulfill your requirement as per your application, right. So, here suppose there is this particular application related to the two surfaces which are in contact, then you can use some type of material which are very high in terms of the wear resistance, and if there is a bending of that, then you can actually use some material which are very high resistance in the bending forces or something like that. And it is hardness, then you can use some type of very hard material. So, here your objective is that because we know the system is very small. So, you can actually select some material without spending in terms of coating or some type of post processing of the component. You select the base material itself with very expensive part and which can fulfill your requirement. So, our objective is that here you can satisfy all your requirement related to the rigidity of the component and the wear stability and the temperature control also, because sometimes we know that the temperature also play important role in our case, and we can select some materials which are very low thermal coefficient of expansion. So, those materials are very costly if you fabricate something at a bigger scale, but here you can directly purchase those expensive material and make the whole structure out of it. So, you can do temperature compensation without any problem. Right. So, reducing the running cost, because now we know that energy consumption is very less because size of the motor is very small, then facility maintenance is also no issue, that is you can easily get this thing done. Air conditioning is very less because now the space required by the machine itself is very small, and the clean room operation, because now clean room operation everything depends on what is the area you are maintaining, right. So, the cost of this clean room cost is directly associated with the space area, right. Because now if suppose you are maintaining a class 1000 or 10,000 of particular rating, then what happens that the area depends on if the small area you have to maintain at that level, then the cost is very less, but the cost will exponentially increase if the area increase, because now you have to maintain the number of dust particle count, the humidity, temperature and some other things also. At that time the requirement of the clean room is very high with respect to area. So, here you can see the total running cost, because we are considering all this parameter as a machine parameter, and so total running cost includes the machine consumption also, what amount of energy and the cost you are spending into the facility maintenance also. So, your total running cost actually reduce very drastically down, and that is the advantage of using micro factories. Some further advantages, that efficient utilization of the space, more machinery can fit in a less space. Now, we know that our object, we have a one big space available, right. Suppose this space is around 100 meter by 200 meter. Now, if you see this space and you have some machine which are very big in size. Now, if this you consider that 20 meter in size in both the direction, then what you can do, actually you can put only 2-3 machine, because you have to provide some space for the material handling also, then cleaning also you require. So, consider you can make maximum you can put 4 to 5 machines here. But now, if you say that if you reduce the size of the machine, now you can actually put many machines there. Suppose now the size is very small, let us reduce this thing to the only 10 meter only, but still it is very big, but still let us see the in comparison of this. If it is a 10, then you can actually multiply by 2 this team directly. So, smaller the size, you can put more machine into that. So, you can efficiently utilize the space for each and every machines. Right. Improve portability and agile reconfiguration. Reconfigurability, easier replacement of machinery and dynamic configurability during demands of variable product and variable quantity manufacturing. So, what does it mean? That suppose you have a small machines here. Now, consider these are placed at different locations. You consider this is a milling machine, layer, this is a drilling, this is press, and the same way, but we let us change the sequence, because now consider that one product is component is going in this direction. This is a component 1. It has a sequence of this operation. First it will pass through milling, lathe, drilling and the press, and then component 2 it has some different sequence. That's, let us consider this is the press, this is the lathe again, this is a milling and this is drilling. Yeah. So, these are the small machines. So, this is a micro machines. Correct. So, now what happens that it is a improved product portability, so easier replacement of the machinery. Now, see that this is the one component and this is the second component. So, one component, consider that you have thousands of this component. So, it is completing these 1000 cycles completely. Now, you are coming with some other component which has a different shape, and for different shape what you have to do, that you have to actually move the this machine in such a way that you fulfill the sequence of the operation. So, this is going here, then this particular milling machine is going at the last operation. So, now what happens that when the size is small, you can easily actually replace the machine with a other machine. So, here you do not require any type of problem in the handling of or the movement of the machine. And dynamic reconfigurability, because now as per your demand, now it is a variable product, now we are changing the product, you can easily shift the machine according to your requirement, and variable quantity manufacturing. Now, suppose one component you are making 50 only, so you can give less importance to that sequence, but suppose one component you are making in thousands of that, then you can easily actually reconfigure the location of the machine, and this will not take much time, because all these things are very small. So, you can do two things together. One is the easier replacement of the machinery, and another is the dynamic reconfiguration when you have a variable products and the variable quantity manufacturing. So, movement is not a problem here, you can easily maintain all the things together. So, that is the very big advantage here, because if you see our conventional that means the micro machine at a conventional size, that means at a meter scale size, once it is installed, movement is very difficult, because we know that there are many things which are actually demands very high precision and no any type of vibration or no any type of disturbance from the outer impact. So, when you move those big machines, at the time there is a chance that it may actually create some problem at the assemblies or the some type of structural problems. So, at that time mostly once the machine is installed, it stay there only for the rest of its life, but that is not the situation here, because size is very small and movement will not take more than one person to move that machine from one location to another location without any damage to the components. Right. So, useful during the military or the space exploration applications, since the accessibility of the large machine tool is very difficult. Now, this example is very important here, because we know that these are the two locations where the size matters, size and the what is the volume. So, here suppose there is a some type of military operation going on, at the time there are some machine weapon or which are damaged because of the some type of attack. So, now you want to replace some small bolt or some you want to do some type of tube fabrication or something at a very small scale, but you cannot move this lathe machine and milling machine, or milling machine big scale, big size machine machine installation or transport is not possible, right. So, these are the application where it is very difficult to move this particular lathe machine or any machine not related to this particular two machines only. So, it will take lot of time also to transport those machine, and then it will create lot of problem at the later stage. So, if you have this type of palm top machine or some type of suitcase size of machine, then what happens that you can easily transport that machine to that location only, and right in the field of that location you can directly fabricate those components which are damaged or which are not in the operating condition. So, here advantage is very high, that means you can transport the machine very easily, you fabricate the component there itself and directly assemble there, so without any problem. So, here there is accessibility is the problem with the big machine, and other than these two there are different other locations also where you can actually get the things done very easily by these small machines. Okay. So, now what are the technical and engineering aspects? Till now we have seen that how it can save the money and the time only. So, but now we have to look at the technical aspect also. First thing is the higher speed. Now, we know that size is very small of this machine, that is the advantage, because now you can go with a very high acceleration without any problem, because we know the low inertia will create a high acceleration, you can easily reach to the required RPM without any problem. So, spindles of machine tools can easily reach extremely high rotational speed, relax restriction on the driving speed values. And we have seen that in micro machining our speed requirement should be very high, and to fulfill that requirement what we need, that we need a very high rotational speed. And we have also seen that if the size is very big, then what you have to do, that you have to give some type of ramp up time, because it is not reaching directly to that requirement part. So, we have seen that initially it is increasing RPM and then it will actually reaching to the target value, target RPM, right. So, you have to spend this much amount of time, let it be in few seconds only. So, this is the ramp up time, right. So, this time will be less if you have a low inertia and you can quickly reach to this location and then you can start the operation. So, and other than that you are not restricting the driving speed value. This is not only higher speed related to the RPM only, but you can quickly move one component, because our objective is to move this component in the x direction and the y direction also. So, if you have a small travel stroke, that means you can easily or quickly move this component. So, total time requirement for the machining of this component is also very less, because you are quickly moving in x, y and z direction, and your RPM of the spindle is also very high. Right. Productivity can be increased by dense and highly parallel allocation of the machinery, that we have seen in that earlier example, that in a same area you can put many machines similar type or the different type also. Suppose you are using a very big milling machine for micro machining, but you put this type of small 5 milling machine within the same area, and then you can do the operation. So, it is very dense structure, that means the number of machines you are putting at the same area is very large here, and you can put the highly parallel allocation of the machinery. So, you put many machines in a line, so you can actually utilize all the machines for a different operations and without creating any problem at the later stage. So, these are the advantages of the going with the micro factories. In a production line, transport distances can be shorter and the material handling equipment will be very lighter. So, this is another advantage, because we know that suppose we have one big machine here, then you have to maintain some space here, right. So, this is the space requirement here on all the sides, to make sure that this machine is accessible from all the sides for different regions. So, now this is the thing, and then you have to mount the other machine which also requires some space between these two. So, this is the other machine, big machine. Now, you are fabricating one component out of it. So, this is one component which you have fabricated, and you want to transfer this component from here to here. So, now your thing is that you have to move this much amount of distance, and then you can actually start doing operation at the next machine. So, your production line will be very large, because now if you consider this is the two machine and there is a third machine again, then the size which is occupied by these particular machines, then it is also large. Transfer distance is large because now you have to keep some machine space here between these two, and that will be also large, and material handling equipment should be also large in this particular case, because now you have to move it away from this location to this location, and sometimes the component is also very large. So, if that is the case in the bigger machine, so if you see the smaller machine here, now this is the small machine. This is the small machines. Now, the space requirement from this side also, it is you require some space from here, but this space will be very small in this case. So, what is important thing here, the production line you can put many machines here. Transfer distance are shorter because now your component will be moved from here to here. Sometimes what happens, you do not require some type of moving component, so something like a robot or something. You need one station here which has one arm, that arm will pick up this part and then it will move directly. That means, you do not require in robotic or station or something which will pick up this part and then it physically moves to this location and then it will float this thing. So, sometimes what happens, that some type of transfer arm or something is important, or sometimes something like the material handling equipment which you can directly feed this thing somewhere permanently, and then it will do all the movement from here to here without any type of physical movement of that equipment itself. It is just moving the component only from one location to another location. So, here what happens, that you are not only saving the space and the money in terms of the machine, but you are actually saving money in terms of the auxiliary operation. So, this transfer of the component from one location to another location is considered as auxiliary operation, because many times you do not require this thing, everything you are doing in the single machine. But many times you are using some type of operations which are in sequence, and that should be performed by the different machine. So, at that time you need this type of material handling and the transfer distance for the different regions. So, these are the advantages of going with this part. So, we will continue this lecture further in the next class. So, let me stop it here and we will see that what other things are there into the next part. Thank you very much.